Your dining table is the scene of a brutal industrial war, with apples arranged in flawless detail. Behind that perfect, blemish-free apple lies a savage industrial battle involving 10 tons of force, where biology is made to submit to cold, ruthless logic. Watch until the end, because once you witness the machine's brutal precision, you will never trust your food again. Have you ever stood in the stillness of a supermarket aisle, staring at a pyramid of perfectly glossy red apples, and suddenly felt a cold sense of unease? Everything is too symmetrical, too perfect, too identical. It feels less like a harvest and more like a mass-produced miracle. The truth is, behind that polished skin lies a brutal industrial war, a battle in which biology has been forced to surrender to the cold, ruthless logic of engineering. We are no longer simply growing food. We are manufacturing life on a scale that should not be possible. We have built machines that can shake the very soul out of a tree, and AI eyes that can judge the worth of a piece of fruit in 1,000th of a second. If you think agriculture is still just a man and a tractor, then you are dreaming. The reality is far louder, far faster, and infinitely more fascinating. Stay with me until the end, because once you see the sheer, merciless precision required to place a single snack into your bag, you will never look at your dinner table the same way again. Before we go deep inside the machine, I want to welcome all of you to this journey. I'm at Nluvwang-04, and if you're captivated by the intersection of raw power and natural beauty, hit the subscribe button. Your support is what keeps us going as we continue exploring these industrial wonders. Now let's set foot in Washington, the apple capital of the world, where the air carries the faint scent of sweet fruit and hydraulic oil. When I look at these orchards, I do not see a landscape. I see a dense network of organic sensors. To meet the global demand for billions of apples, we have created mechanical dancers, shaking machines that weigh as much as 10 tons. I find it truly fascinating to watch these giants at work. A massive hydraulic arm clamps onto the trunk, and within seconds it generates vibrations tuned with near-perfect precision. It is a violent symphony. The tree trembles, the fruit falls like rain, and in that instant, the biology of the tree is completely dominated by mechanical force. But the more I analyze it, the more I realize that this brutality has been calculated. Leaf sweepers move in, followed by harvesters fitted with soft rubber fingers spinning like mechanical hands. I often wonder, what does this do to the lifespan of the tree? We are trading the tree's peace for a harvest of 15 tons a day. Still, there is a hierarchy here. The apples shaken loose and dropped to the ground are used for juice, because even the slightest bruise instantly reduces their value. For the premium market, the apples the elite will buy, the technology has to be even more sophisticated. Now we use catching frames that unfold like high-tech umbrellas, catching the fruit in mid-air to prevent any contact with the ground. But the true aha moment, the moment that marks the end of the human era in the orchard, is the arrival of AI-powered robotic arms. I have watched these robots work, and it is astonishing. They do not grow tired. They do not blink. Equipped with neural networks, they scan for ripeness and extend their grippers with a precision that makes the human hand look clumsy. This is the industrial pulse I'm talking about. We have moved from the roughness of the soil to the glow of sensors, where the economic value of an entire harvest is decided by a line of code in the blink of an eye. This is where our story begins. If the orchard is a high-tech ballet performed in mid-air, then what happens beneath our feet is a brutal heavyweight wrestling match against the very crust of the earth. We are leaving the canopy behind and diving into the hardened soil, because to understand how we feed billions, we have to confront the raw power required to tame the land. I have spent a great deal of time thinking about the stubborn resistance of soil. It is dense, heavy, and compacted by seasons of sun and rain, and yet we have built machines that treat it like soft butter. Let us travel to the vast flat plains of the Netherlands and Germany, where the pursuit of orange gold turns the landscape into a massive industrial extraction site. The first time I saw the Grimme Evo 280 harvester in action, it did not feel like farming. It felt like a rescue operation, This is not just a tractor pulling a plow, it is a mobile geological event. Carrots are secretive creatures buried deep inside compressed earth, and the Evo 280 is designed to solve that hidden problem with astonishing efficiency. I was captivated by the way it tears through a field, shaking off layers of centuries-old soil, slicing away the green tops, and preliminarily sorting the harvest in one continuous mechanical roar. It is a spectacle of industrial-scale logic, where a single machine replaces the aching backs of hundreds of workers. Watching thousands of bright orange carrots stream across conveyor belts from above, you begin to realize this is not only about food, it is about engineering's total victory over the physical limits of the earth. But then, when you turn to onions, the energy seems to shift from brute force to carefully calculated patience. Onions are the delicate aristocrats of the root crop world, and they demand a curing process that I find endlessly fascinating, even in a mechanized system. They are not rushed straight into storage bins. Instead, a bulb lifter raises them from the soil and lays them in long windrows to dry under the sun for 2 weeks. Why? Because we are waiting for sunlight to create a protective armor, the dry, papery skin that stands between a fresh onion and a pile of rot during a transcontinental journey. It is a moment when the industrial rhythm must submit to the rhythm of weather, a rare pause in the machinery. And we cannot talk about this harvest without mentioning the true muscle behind it all, the deep plow. I have stood close to these machines as they rip through the earth, and you can feel the vibration in your teeth. These enormous blades cut 60 to 70 centimeters deep, and that makes me wonder about the cost of such intensity. We are not simply turning over soil, we are shattering the hardpan, the suffocating compacted layer that roots cannot penetrate. We use this immense force to give the soil its breath back, allowing air and water to flow into the deep beds. Whether it is the brutal strength of the deep plow or the more skillful blending of organic matter with shallow tillage, every pass of the blade is a deliberate choice. It is a reminder that before we can reap the harvest, we must first win a war against the ground itself, transforming a silent, resistant field into a perfectly engineered seedbed.
While we have witnessed the sheer physical force required to break open the earth, a different kind of intensity emerges when the target is not rock or soil, but the most fragile forms of life in the field. We are moving from a brutal battle underground to a high-speed, high-risk race against biological decay. In this realm of agriculture, the enemy is not the resistance of the soil, but the relentless ticking of a clock we cannot stop, only hope to outrun. This is the frantic world of perishable food, and that pressure is nowhere more evident than in the sweet cornfields of the American Midwest. I have always been haunted by how the peak perfection of a crop can be so brief. Sweet corn exists only in the milk stage, that fleeting window when the kernels are swollen with natural sugars. If we miss that stage by even a single day, the plant's biology betrays us. Those sugars turn into dull, mealy starch. It is a tragedy of chemistry. To overcome this, we have built harvesters that are essentially mobile assembly lines, cutting the stalks and stripping the ears in seconds. In the United States, we plant hundreds of thousands of acres of this crop, yet the astonishing reality is that nearly 90% of it will never reach the fresh produce shelves. Within 8 to 12 hours, the corn is locked in a race from stalk to canning line, trying to preserve a sweetness that nature only intended to last for a moment. It makes me wonder whether we are eating corn or consuming a preserved memory of what it was meant to be. Then, there is the raspberry, a fruit so delicate it almost seems like one of nature's mistakes. I have spent a great deal of time studying the raspberry's hollow core. It is a beautiful, airy structure formed when the fruit separates from its receptacle. But as I came to understand, that hollow is a biological trap. It becomes a refuge for microscopic bacteria and mold spores, hiding in crevices too small for the human eye to see. This fragility forces us into an obsession with technology. In Washington State, We use mechanical harvesters worth a fortune that do not pick so much as whisper. They use fiberglass rods to shake the canes at such a precise frequency that only perfectly ripe berries, those ready to fall, drop onto the conveyor. The processing plant is where my curiosity is stirred most deeply. Here, the berries are treated with a reverence usually reserved for precious crystals. They are washed with ultra-low pressure water jets calibrated to just 0.3 bars. To put that into perspective, that is less than half the pressure we would use on a sturdy apple. Any stronger, and the skin would split, the juice would run, and the fruit's value would evaporate. They are moved along gently vibrating conveyors to ensure that no two berries touch or cling together before entering the deep chilling zone. It is a seamless process, cold, efficient, yet still expressive of care and speed. We are spending millions of dollars on sensors and cooling technology simply to preserve an aroma, a delicate beauty, and a juice that begins to deteriorate the instant it meets the air. It reminds us that in the industrial heartbeat of agriculture, the greatest display of strength can sometimes be the capacity for extraordinary gentleness. However, even after we have mastered the art of handling the most perishable berries, we eventually come face to face with crops built on the cold logic of mathematics, seeds and nuts, the durable reserves that underpin our global food supply. Moving from the humid, frantic heat of raspberry harvest into the dry, calculated world of seeds feels like stepping out of a hospital ward and onto a chessboard. Here, nature's beauty is not merely a byproduct. It is a blueprint we have learned to exploit with unsettling efficiency. Take the sunflower, for example. I have always been fascinated by the fact that a sunflower is not simply a flower, but a complex biological machine that follows the Fibonacci sequence. Those spirals are nature's way of packing the maximum amount of life into the minimum amount of space, the golden ratio in bloom. But once industry arrives, that sacred geometry is treated as raw data. The combine harvester does not care about the beauty of the spiral. It cares only about the glossy black seeds hidden inside. As the header feeds the stalks into the threshing drum, the withered flower heads are crushed in an instant, and what was once a field of towering blossoms swaying in the wind becomes, quite literally, a river of seeds. It is the moment when nature's ancient mathematics collides with the modern hunger for cooking oil, and the transformation is efficient but utterly devoid of nostalgia. Then there is the peanut plant, a crop that demands a strange and almost theatrical two-step process. Because the pods ripen underground, harvesting becomes an act of exposure. First, a digger shaker slides its blade beneath the soil, cuts the roots, and flips the plant upside down, leaving the peanuts exposed to the sun. It is a startlingly vulnerable sight, millions of peanuts suddenly dragged into the light. Only after they have been cured by wind and heat does the combine return for its grand finale, stripping the pods from the vines at a rate of 6 tons per hour. It is a choreographed dance, machinery turning a buried secret into a massive economic commodity. But perhaps the most striking example of our determination to override nature appears in the perfect circles of the American desert. When I look at satellite images of Nebraska or Arizona, I see vast green discs etched into the sand, the signature of center pivot irrigation systems. We are talking about pipelines stretching hundreds of meters, rotating like the hands of some cosmic clock. A single system can turn 130 hectares of barren land into a lush oasis of peanuts or soybeans, sustained by just one central well. It is an engineering masterpiece, yet when I study the sensors and smartphone controls that optimize every square meter of water, I cannot help feeling uneasy. We are deploying enormous amounts of technology to sustain life where it was never meant to thrive. We have turned the desert into a factory, and while GPS-guided seeders can ensure a uniform germination pattern that a 19th century farmer could never have imagined, one still has to wonder whether we are conquering the land or merely borrowing time against an increasingly thirsty future. This is the kingdom of seeds, where every row is a line of code and every drop of water is a carefully calculated investment. When the dust of the field settles and raw crops cross the threshold into the factory, the organic world finally surrenders its wildness to be sealed inside a sterile industrial shell. We leave behind sunlight and soil and step into a world of neon lights and stainless steel, a place where harvests are refined, sorted, and reborn as global commodities. I have always found this final transformation to be the most unsettling part of the story, because it is here that a simple fruit is stripped of its identity and turned into a masterpiece of supply chain logic. Take the pineapple, for example. Although Costa Rica also grows pineapples, the true pineapple king lies in the massive factories of the Philippines, which produce more than 40% of the world's pineapple supply. Watching a pineapple enter the processing line is like watching a king lose his crown. In just seconds, a peeling system equipped with intelligent sensors removes the spiky outer skin that once protected it. I often feel a strange sense of loss seeing that tough shell torn away in an instant, leaving behind only the exposed golden flesh. A hollow coring tool then drills out the center, creating perfect pineapple rings neatly arranged inside gleaming cans like tropical jewels. It is a total transformation, turning a rugged fruit into a marvel of convenience. But nowhere is the elitism of machinery more visible than in the final almond sorting stage. This is where supercomputers take over, evaluating each almond with digital objectivity. I find it fascinating that we have built neural networks simply to detect a microscopic scratch. The elite almonds are separated from the rest with absolute precision, creating a hierarchy in which only the most flawless nuts are chosen for premium salted almonds or fine almond toffee. It is also here that we witness the final transformation into almond toffee, where butter and sugar are melted at the precise temperature of 155 degrees Celsius to create a smooth, chewy coating. Once covered in chocolate, these pieces receive a golden rain, a shower of roasted almond bits that forms a crisp, fragrant outer layer. It is a harmony of textures engineered to awaken the senses. When I look at the finished cartons ready to cross the ocean, I cannot help but reflect deeply. Every almond and every slice of pineapple is proof that we refuse to let nature remain merely good enough. We have used 10-ton grinders and AI eyes to build a world where hunger is met with absolute precision. In this pursuit of industrial perfection, I have to ask, what have we gained and what have we quietly left behind in the mud? This is at Enlu Vuong-04, and when these technological trophies reach your table, I invite you to see them not merely as food, but as the carefully calculated heartbeat of a world that is finally mastered machinery. Ending. We have just traveled a long journey from dusty fields where 10-ton machines shake the ground itself to sterile factories operating with millimeter-level precision. In the end, what we have seen is not merely agriculture. It is an invasion of industrial logic into the natural world. Every perfect almond and every golden pineapple ring is a prisoner of a strict supply chain management system where even the slightest deviation is mercilessly removed. We are living in an age where order, uniformity, and speed have become sacred principles. Technology has freed humanity from physical hardship, but at the same time, it has turned food into something pre-programmed. In that, we can see the greatness of human intelligence, but also the coldness of algorithms when they decide the value of everything based on visual perfection. A deeper lesson. The perfection we see every day is the result of a ruthless process of optimization. In agriculture, without discipline and precision, the system collapses. How to apply this to life? Learn to run your life like a high-tech production line. Be disciplined in your process, but cherish your core values. To achieve great success, you need the precision and steady effort of a machine. However, never let the illusion of perfection erase your personal identity. Remember that just as a delicate raspberry requires special care, your inner values also need protection from the pressure of the fast-spinning industrial world outside. After witnessing the terrifying power of machinery in today's video, do you place your trust in the perfection of technology, or do you still prefer handmade, more natural products? Leave your thoughts in the comments below so we can discuss them together. And do not forget to hit subscribe to @nluvuong-04 so you can continue joining me on future journeys exploring the next industrial wonders. Your support is my greatest motivation to create even deeper and more meaningful content. And ayuban mun katelam tip mut ban mut hon tokyo voiceover YouTube mai ngetu nien cinematic hon bangdit sat ngianay.